Therapsida is a group of synapsids that includes mammals and their ancestors. Many of the traits today seen as unique to mammals had their origin within early therapsids, including having the forelimbs extend vertically beneath the body, as opposed to the sprawling posture of other reptiles. The earliest fossil attributed to Therapsida is Tetraceratops insignis from the Lower Permian. Therapsids evolved from pelycosaurs 275 million years ago. They replaced the pelycosaurs as the dominant large land animals in the Middle Permian and were replaced, in turn, by the archosauromorphs in the Triassic. Although one group of therapsids, the Cantmaiforms, remained diverse in the late Triassic, the therapsids included the cynodonts, the group that gave rise to mammals in the late Triassic around 225 million years ago. Of the non-mammalian therapsids, only cynodonts and dicynodonts survived the Triassic-Jurassic extinction event. The last of the non-mammalian therapsids, the tritolodontid cynodonts, became extinct in the early Cretaceous, approximately 100 million years ago. Characteristics. Compared to the pelycosaurian ancestors, early therapsids had very similar skulls but very different postcranial morphology. Legs and feet. Therapsids had legs positioned more vertically beneath the bodies than were the sprawling legs of reptiles and pelycosaurs. Also compared to these groups, the feet were more symmetrical, with the first and last toes short and the middle toes long, an indication that the foot axis was placed parallel to that of the animal, not sprawling out sideways. This orientation would have given a more mammal-like gait than the lizard-like gait of the pelycosaurs. Jaw and teeth. Therapsids' temporal fenestrae are relatively larger than those of the pelycosaurs. The jaws of some therapsids are more complex and powerful, and the teeth are differentiated into frontal incisors for nipping, great lateral canines for puncturing and tearing, and molars for shearing and chopping food. Fur and endothermy. Several characteristics in therapsids have been noted as being consistent with the development of endothermy. The presence of turbinates, erect limbs, highly vascularized bones, limb-in-tail proportions conducive to the preservation of body heat, and the absence of growth rings in bones. Therefore, like modern mammals, non-mammalian therapsids were most likely warm-blooded. Recent studies on Permian coprolites showcase that hair was present in at least some therapsids. Hair is by any means present in the docodont Castorocauda and Haramedon megaconus, and whiskers are inferred from their ossifalans and cynodonts. Evolutionary history. Therapsids evolved from a group of pelycosaurs called sphenecodonts. Therapsids became the dominant land animals in the Middle Permian, displacing the pelycosaurs. Therapsida consists of four major clades: the dinocephalans, the herbivorous anomidons, the carnivorous piamosuchians, and the mostly carnivorous theriodonts. After a brief burst of evolutionary diversity, the dinocephalans died out in the later Middle Permian, but the anomidont dicynodonts as well as the theriodont gorgonoptions and their ossifalans flourished, being joined at the very end of the Permian by the first of the cynodonts. Like all land animals, the therapsids were seriously affected by the Permian-Triassic extinction event, the very successful gorgonoptions dying out altogether and the remaining groups, dicynodonts, their ossifalans, and cynodonts, reduced to a handful of species each by the earliest Triassic. The dicynodonts, now represented by a single family of large stocky herbivores, the Cantmairidae, and the medium-sized cynodonts, flourished worldwide throughout the early and middle Triassic. They disappear from the fossil record across much of Pangaea at the end of the Carnian, although they continued for some time longer in the wet equatorial band and the south. Some exceptions were the still further derived eusynodonts. At least 3 groups of them survived. They all appeared in the late Triassic period. The extremely mammal-like family, Tritylodontidae, survived into the early Cretaceous. Another extremely mammal-like family, Tritylodontidae, are unknown later than the early Jurassic. Mammaliiformes was the third group, including Morganeucodon and similar animals. Many taxonomists refer to these animals as mammals, though some limit the term to the mammalian crown group. The non-eucynodonts survived the Permian-Triassic extinction. Thrinaxodon, Galesaurus and Platycranialis are known from the early Triassic. By the Middle Triassic, however, only the eucynodonts remain. The Therocephalans, relatives of the cynodonts, managed to survive the Permian-Triassic extinction and continued to diversify through the early Triassic period. Approaching the end of the period, however, the Therocephalans were in decline to eventual extinction, likely outcompeted by the rapidly diversifying saurian lineage of diapsids, equipped with sophisticated respiratory systems better suited to the very hot, dry and oxygen-poor world of the end Triassic. Dicynodonts were long thought to have become extinct near the end of the Triassic, but there is evidence that they survived into the Cretaceous. The fossils have been found in Gondwana. This is an example of Lazarus taxon. Other animals that were common in the Triassic also took refuge here, such as the temnospondyls, mammals are the only living therapsids. The mammalian crown group, which evolved in the early Jurassic period, radiated from a group of mammaliiforms that included the docodonts. The mammaliiforms themselves evolved from Probaenognathians, a lineage of the eucynodont suborder. Taxonomy. Classification: Class Synapsida. Order Therapsida*. Family Tetraceratopsidae. Suborder Biomosauchiera*. Family Biomasuchidae. Family Eotitanosuchidae. Therapsida. Suborder Dinocephaliae. Family Astemonasuchidae. Infraorder Antiosauria. Family Antiosauridae. Family Brithapodidae. Family Deuterosauridae. Family Sciodontidae. Family Stenosibidae. Tapinocephaliae. Family Styracocephalidae. Family Tapinocephalidae. Family Titanosuchidae. Neotherapsida. Suborder Anomodontia*. Superfamily Venucoviomorpha. Family Ocheridae. Family Venucoviidae. Infraorder Dromosauria. Family Galeopodidae. Infraorder Dicynodonta. Family Endothodontidae. Family Eodicynodontidae. Family Kingauridae. Diictodontia. Superfamily Emidopodia. Family Cystocephalidae. Family Emidopodidae. Superfamily Robotoidea. Family Diictodontidae. Family Robotiidae. Priscodontia. Family Aulocacephalodontidae. Family Dicynodontidae. Family Cantmaiidae. Family Lystrosauridae. Family Audnodontidae. Family Priscodontidae. Family Shanaziodontidae. Family Stalochiridae. Theriodontia*. Suborder Gorgonopsia. Family Gorgonopsidae. Eutheriodontia. Suborder Therocephaliae. Family Lycasuchidae. Psilocosauria. Family Psilocosauridae. Infraorder Eutherocephaliae. Family Hoffmyridae. Family Moschurhunidae. Family Waitziidae. Superfamily Bowerioidea. Family Boweriidae. Family Erisioloctridae. Family Ictidsuchidae. Family Ictidosachopsidae. Family Lysidiopsidae. Suborder Cynodontia*. Family Vineyardae. Family Procynasuchidae. Epicynodontia. Family Galesauridae. Family Thrinaxodontidae. Infraorder Eucynodontia. Synognathia. Family Synognathidae. Family Diademodontidae. Family Travisodontidae. Family Trirachodontidae. Family Tritylodontidae. Probaenognathia. Family Chinchodontidae. Family Probaenognathidae. Ictidosauria. Family Tritylodontidae. Mammaliiformes. Class Mammalia.